Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very interesting equation with trigonometric functions, or we're going to attempt solving an equation. Anyways, let's see how this goes. We have tangent z equals I, and remember, I is the imaginary unit, the number whose square equals -1. Some people also define it as the square root of -1, but you gotta remember it's one of the square roots of -1, because in the complex world, -1 and any other number besides 0 has 2 square roots. Okay, great, let's get started. Now, to be able to get to tangent, I think we talked about this in the lecture videos, so go ahead and watch them if you are new to complex numbers or if you wanted to just refresh your knowledge. So we do have a formula called Euler's formula, which is super duper nice. Of course, anything that Euler worked on is awesome, because Euler is awesome, in my opinion. So let's go ahead and write it down. What does Euler's formula look like for a complex number or any other number? Cosine z plus I sine z equals e to the power iz. Okay, so that's Euler's formula, and this actually allows us to write a complex number. I could probably put the e to the iz on the right hand side, which is a little better. So this allows you to write a complex number in standard form, and of course z is a complex number too, but cosine z plus I sine z is also a very complex number. It allows you to write it in a very compact form, writing it just as an exponential, which is amazing. Okay, now we want to get to tangent, so we're going to do the following. First of all, we want to get to sine and cosine. So let's go ahead and replace z with -z. So it's going to give us cosine of -z, which is the same as cosine z because cosine is even. But unfortunately, sine is an odd function. Sine is really odd. So it's going to be a negative sine z. And on the right-hand side, of course, you're going to have a negative iz. Now, if you go ahead and add these two equations, what do you get? You get the cosine z twice, but sine z cancels out, and you end up with something like this, which gives us the value of cosine z when divided by 2. So cosine z can be written as e to the iz plus e to the negative iz divided by 2. Similarly, sine z can be written as, of course, if you subtract the equations and divide by 2i, not just by 2, you're going to get e to the iz minus e to the negative iz divided by 2i. That's going to be your sine z. Okay? Now, what do you do with those? If you're trying to get to tangent, you would divide sine by cosine, because tangent z, or it's kind of like a tans, right? Tangent z is sine z over cosine z. But sine z is e to the iz minus e to the negative iz over 2i, and flip cosine z, which is going to give you 2 over e to the iz plus e to the negative iz. 2 cancels out, and that's the only thing that cancels out. And of course, you can multiply the top and the bottom by negative I, because negative I times I is negative I squared, which is equivalent to positive 1. A lot of times people are going to multiply by I and then they have to handle the negative. I just directly multiply by negative I, no big deal. This is just 1. And the top is just going to be flipped and multiplied by I, so I could write it as follows. Tangent z equals I times e to the negative iz minus e to the iz, because the negative flips, right? And at the bottom I have e to the iz plus e to the negative iz. So that's the tangent z in terms of the exponentials. And now what are we going to do with this? Well, remember, the equation said, the original one said tangent z is equal to I, right? So if you set this equal to I, you should find the answers, right? Wrong. That's not true. But you'll see why, because it's going to be interesting, in my opinion. You decide. Now, since we have I on both sides and I does not equal 0, as far as I know, I squared equals -1. So we can go ahead and cancel out the I, multiplying both sides by 1 over I, or just dividing by I. We end up with 1, so we can go ahead and set the numerator and the denominator equal to each other, which is great. So let's go ahead and do it. Wait a minute. We have the same thing on both sides. So why not just cancel those out, right? What am I talking about? E to the power negative iz. We can go ahead and cancel it out. And I put e to the iz on both sides, negative 2 e to the iz equals 0, because we're subtracting e to the iz. Make no mistake, we're not dividing. What happens if you divide both sides by e to the power iz? So something interesting happens. If you do it, you're going to get something like this. Negative e to the iz divided by e to the iz equals 1. And they're gonna, when these two cancel out, you're going to get something like negative 1 equals 1, which doesn't make sense at all. So don't divide, just add or subtract. Okay? And if you divide both sides by negative 2, you're going to get e to the iz equals 0. What are some of the solutions? It's like, what? Are you serious? Well, this equation doesn't have any solutions, unfortunately. Well, it kind of does, doesn't it? Well, iz is negative infinity. From here, you can get z is equal to I infinity, because you can multiply both sides by negative I. Uh-oh, this is not going to work. This is just a joke. Don't take it seriously. Obviously, negative infinity is not a number, so that's not a solution. Okay, so what are the solutions then? There are no solutions. That's it. We've done all this work for nothing. Well, okay, this one doesn't have any solutions, but what do you think about another equation, which I'm going to leave with you? This one doesn't have a solution. Okay, bad, right? But what about e to the power iz equals 1? Does it have a solution? Because if e to the iz is 0, then this is true. But if this is true, does that imply the other equation? Something to think about. So I'm going to leave that with you. And before we finish this video, I want to show you something else. Now, we started off with an equation, tangent z equals I, right? That was our original problem. Why didn't we end up with a solution, right? So let's go ahead and use basic trigonometry. Even though z is a complex number, let's just pretend everything is normal. And we can draw a right triangle. Let's go ahead and see what that looks like. Now, in a right triangle, tangent is defined as opposite over adjacent. Therefore, if tangent z is equal to I, this length is supposed to be I. In the complex world, just pretend that it exists. And this length can be 1, so that the ratio is going to be I, right? So far, so good. But what about the hypotenuse? I don't know what it is. Let's just go ahead and call it, what should we call it? I don't know. Let's just call it y. I don't know why, but let's just call it y. And now let's use the Pythagorean theorem on the complex world. And that gives us I squared plus 1 squared equals y squared. But I squared is negative 1, so this is negative 1 plus 1 equals y squared. So y squared equals 0, and y equals 0. So y does not exist. That's why you can't find a solution. Of course, that's kind of like a geometric explanation why the solution does not exist. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.